Okay, guys, so here we're solving one of the problems in our exams, and this is the bullet and the block problem. So this is an impact problem. The bullet is going to start with this momentum, MVA1, and then obviously when it hits the block, it's going to experience a negative impulse, basically, that is trying to slow down this, right? And ultimately, the bullet is going to be traveling with a velocity of mva2, right? Now we're going to do the same thing on the block. The block initially had no momentum, but it actually had a force applied on it. So we basically have the same impulse is going to be imparted also on the block, right? And this impulse is going to give you this new velocity, but then they tell you that the bullet basically gets stuck inside the block, right? So here you are going to have large M, but multiplied by VA2 because now they have the same velocity, right? So MVA2 is actually equal to VB2, so I just made them like that equal, right? So now if I sum the impulses on the whole system, I'm going to have MVA1 here minus FDT and then FDT. So these two will actually cancel out, and then this is the key of solving impact problems, because the impulse is going to be equal on the opposite. So you end up with VA1 is going to be equal to, so the bullet gets stuck in this, so they have the same velocity. I can basically rearrange this and then write it like that, right? And
Yes.
then, so basically you solve for VA2 is going to be equal to M over M plus M multiplied by VA1. So now you have, this is the velocity of the block and the bullet after that the bullet hits this. Now, if you would like to get the maximum compression of this, right, there are several ways you can do it. You can do acceleration, analysis, summing the forces. The easiest way here is basically to look at the kinetic energy and the energy that is stored in the spring, right? So I know the total energy of the system, which is going to be equal 1 over 2. Now, you want to take the kinetic energy of both the block and the spring. Since M plus M VA2 squared is going to be equal to the energy in the spring, right? 1 over 2K. The energy in the spring, when the spring is compressed, it's going to be 1 over 2K times, I'm going to put it D squared, where D is going to be what? The deflection of that spring from here maybe to here, right?
Yes,
so that's
okay.
it, right? So D is going to be equal to M plus M over K square root of this guy multiplied by VA. So you see, really, it's like, 2-minute problem, right? Okay, so next time I'm gonna ask you guys to show me this, right? And that's it.
Okay,
Yes,
thank you,
doctor.
doctor.
Yes.
And you wanted from this problem the an idea, know how much compression?
No, there was actually several alternation of this problem. One of them was to get the maximum deflection. I think the other one was to get
Average
what?
force.
The average force, exactly, right. Okay, so the other problem was to get the average force. How do you get the average force? You can actually use this, okay? So we know F is basically the force applied on the block and also applied on the bullet, right? Because it's equal and opposite. So I know F dt is going to be equal to what? M, big M, VA2, right? I gave you dt basically, and VA2, which is from here. We can basically solve F is going to be equal to M VA2 over dt, right? Which is M times VA2, which is this guy, M plus M VA1 over dt, right? This is going to be your average force.
Okay, thank you, doctor.
Okay. Okay, guys, any more questions on this? I guess. If not, then let's go ahead and then continue with solving our, working on our instantaneous interpretation. And actually, before I do that, let me just do a quick recap. So we said if you have a rigid body, right, and that rigid body is, let me just, brightness is not, Not updating very quickly. Okay, so if I have a rigid body, right, and if I gave you this is point A, and I know that point A basically is like that, it has this velocity, and if I gave you point B has this velocity, right? Now, can I ask you to find the velocity of point C? Can someone tell me how can you find the velocity of point C?
We draw two lines perpendicular.
Exactly, you draw the lines perpendicular to this and then perpendicular to that, right? So I know the instantaneous center of rotation has to be located somewhere along this line, right? It could be either here, here, anywhere, right? And again, on VA, I will also be able to draw this. So this is the instantaneous center of rotation. So it means that, why is it called instantaneous? It means that this rigid body, at this instant, it is rotating about this point I, right? And VI basically is equal to 0, right? If I were to actually find the velocity of this point, how do I get the velocity of this point?
Which one, Dr. C?
Let's say this point.
We join I and this point to perpendicular عليه.
Exactly, it's going to be perpendicular to this, right? And then the magnitude of this is going to be the distance between I and this point. So basically, I'm going to actually draw you guys something, and then, so the velocity at this point, it's going to look like that, right? You guys agree, right? And the velocity of this point is going to look like this. This is basically like, you know, profiling the motion on this, right? Why? Because let's say this is point Q, VQ will always be equal to omega multiplied by the distance, right? IQ, right? So if IQ is 0, the velocity is 0, right? And then as you are going away from the instantaneous center of rotation, your velocity increases proportionally, right, to the distance, right? So just know that, okay? So this is an important thing to know. And then the velocity of point C, again, you just draw this. Okay, and the velocity at C is going to be equal to omega multiplied by IC. All right. Okay, so that is it. I want to give you guys actually an exception to this, right? And here we know omega is going to be like this, okay? We just know the direction of omega based on one of the velocity vectors. So I obtained I. I know this dA is like that. Therefore, this rigid body is like, you know, spinning like this in that plane, and we got omega. All right. But what happens if I gave you this rigid body, let's say, right? And let's say the velocity of A is like that. And let's say I gave you the velocity of B, okay, is like that. How do you find omega? Can someone tell me how do you find omega here? Like the value, I need to find the actual value of omega. Okay, I think if you actually had this situation, then you have a little issue. Why? So we know, let's just do the approach that we did. So do this, and then if you do this, then your instantaneous center of rotation is going to be here. But what is the issue? So if you consider this point, then you know omega is going to look like that. But if you consider this point, then omega is going to look like this, right? So this is an issue, right? So when you want to, does it make sense, right? So if I use point I, if I use point A will actually tell me that this is my omega, and point B will actually tell me this omega. So if I actually, to satisfy the kinematics of that rigid body, I only can have one omega, right? So therefore, VB cannot be like that, right? So if you actually had a sensor here, then VB actually has to be like this. So this guy here would be wrong, right? So this is the proper motion, and then this is my omega. So now this rigid body is rotating about this point I, And because of this rotation, then this guy has to obey the rules of kinematics, and therefore it would have this velocity. All right, so this is the only thing that I wanted to add today to this. So just, be careful. Obviously, you need two velocity vectors, right? But you actually just need one velocity vector and direction, and the other velocity vector you just need to know just like the line of the vector, how the vector is basically positioned, right? And then from there you'll be able to get I, and you'll be able to get I. All right, so that is it here. I'm gonna stop this, and then I wanna share my screen, and then we can go from here. All right, so this problem is what we did last time, right? And we did it, and now let's work on this problem. So in this example, basically, what we have is, this is like the yo-yo, right? And this is rotating about point A, and omega is equal to 4 radian per second. We would like to find the velocities of point A, B, and then C. Can someone tell me what is the velocity, or how can I find the velocity of point B on this disk?
I use VO because it's the center, so VO equals to 0.
Okay. Okay.
And I have omega, so I can find VB.
Why is
and
VO equal, but why is VO equal to 0?
It's not the center of the circle.
Well, here's what, right? So the center of the circle doesn't necessarily have a zero velocity. Like the center of
it's
the
moving, no?
Exactly.
It's moving downward.
Exactly. Point O is moving downward, right? So point O doesn't have zero velocity. What point has a zero velocity?
I need to use
D.
D.
D, exactly. So point D has zero velocity. But okay, how do you go from here? If you choose point D, like you don't actually have the dimensions. You don't have, like, let's say your point D was your reference. You don't have the vector RC with respect to D, right?
Yes, we don't have it.
How do you do this? Like, how can we do this?
Isn't A the instantaneous center of velocity?
I'm sorry, which point?
Point A.
Why point A is the instantaneous relation?
Because it belongs to the rope as well, and it's not moving.
Exactly. This is very good. Yes. So point A, guys, belongs to the rope, right? And as the rope unwraps, let's say you're actually holding point A at that instant. Can you actually move it down? You can't, right? Point A cannot move at every instant. Basically, point A is part of the rope, right? And although while you are unwrapping, right, you are basically moving to a new point on the rope, but the current point on the rope is not moving, right? So this is very important. So point A has zero velocity, and from here it becomes very simple analysis, right? So we know VA, right, equal to 0. So now I can find VO, right? So VO is going to be equal to VA plus omega cross R A with respect to, no, O with respect to A. Okay? So VO is going to be equal to how much? It's going to be omega, right? Omega
Yes.
cross R O with respect to A. And here, what is omega in this case? Let's say you have this IJ frame. Let me throw it like that.
Minus 4K.
Exactly. Let me just throw that frame I. So we have I and then J. Okay. So we know omega in this case is going to be equal to minus 4 times K, right? Cross RO with respect to A, which is how much? 0.15. Okay. And then that is going to be equal to how much? K cross I is equal to, so we have I, J, K.
Equals to J.
Exactly. K cross I equal to J. I need to learn them because I always have to do this. 0.115 times J. Okay, so that's it, right? This is your result. All right, so obviously, which makes sense, right? So point O is actually moving downward with this velocity. And how about if I want to find the velocity of point B?
Which point? B?
B, yes.
the same thing.
Exactly.
بس الار بتغير. الار بتغير.
Exactly. So if I use the velocity of V, then I'm going to have to choose this different point. So I'm going to do VB. It's going to be equal to. So do you think, can I use VA or VO as my reference? Does it matter or no? Can I use VO? So
yes.
exactly. So I can actually exactly use VO cross R B with respect to O, which is actually equal to VA plus omega cross R B with respect to A, right? So let me. Right, so this is the same results. I could use VO, but I have to use this as my reference, or I could use VA, but I would have to use a vector from B to A. So again, here it's going to be, the same. So all I have to do here is I'm going to use VA as my reference. So I would just simply add minus, right? Omega is going to be minus 4K cross RB with respect to A, which is 0.3, right? 0.3K, which is going to be twice. Okay, so it's going to be minus 1.2. Okay, you guys agree?
0.3i, doctor.
0.3i, yes, thank you. All right, which is going to be equal to this. Guys, so really, it's really simple. Okay, and then I can find the velocity of E using the same formula. I could use point B as my reference, point C, or whatever. Let us find the velocity of point C, and then that would be it. I want to find the velocity of C. And by the way, I would at some point I want to give you guys like just one online lecture on MATLAB, and then I can show you guys how we can quickly do these very small introduction to MATLAB, which is not going to be included in your exam or anything. But I'll just do this to show you guys how you can, like, for example, simulate this in MATLAB, and then you can see how it falls. You can find the velocity, acceleration at any point, find the force in the rope, plot it as a function of time. You can pretty much do anything that you want, and then this is very valuable thing to use. So if I want to find the velocity of C, I can actually use VB or I could use VO. So let's say we use VO, right, plus omega cross R what C with respect to O, which is going to be equal to VO, which is minus 0.6 J plus omega, which is minus 4K. And then this guy is cross RC with respect to O, which is equal to 0.115 J, right? And so this is equal to minus 0.6 J plus K cross J is minus I, right? K cross J because we're going backward, minus I, so minus is plus. So plus 4 times 0.115 I, right? So it actually has some components in the I directions. And this guy is going to be equal to minus 0.6 J plus 0.6 I. So the velocity vector at this point C, it's going to have some negative components, right? Let me change the color of this and make it red. So it is going to have this component in this direction, and then it's going to have this component in that direction, right? Which makes sense, right? So,
yes.
and they are equal, okay? They are equal. So if you actually do this line, right? Let me change this to black because this is my vector. So if I choose my point A as my reference, then obviously the total velocity vector is going to be perpendicular to this, right? And then it's going to be this, right? And then they are equal. So this angle is 45 degrees, right? And then I know this angle is 45 degrees because I have one radius here and then one radius up, right? So, what I want to tell you here is that in kinematics, it has to make sense, right? Because if you throw an object in the air, it always has the same thing. Obviously, assuming that perfect motion, and then you have no changes, etc. So kinematics will always work out no matter what you do. You end up with the same result. Okay, any questions, guys, on this? Are we good? I think that's it. So let's go to another problem. Okay. So here, what we have is this is a crankshaft, right? So this crank rotates, and then as a result of the crank rotation, this part AB, this mechanism will basically move. This is actually called a 4-bar linkage, which is what you are going to learn later on in your kinematics and dynamics of linkages. So all these links are connected with pivots, and here what we have is that they gave you the angular velocity of link AB, and from this angular velocity we would actually like to find the angular velocity of CD, right? That link. And how do you guys suggest that we can do this?
We get VB because VA is 0.
So we get VB. Okay, let's plot it. So we have VB now. Okay. And we know VB, by the way, right? We know VB is going to be equal to how much? It's going to be equal to
Omega.
50 times 0.1, okay? In the J direction. We already know that for sure now. Okay? It's easy.
Yes.
And this is going to be equal to how much? To 5, right? 5 J, right? And then this is in meters per second. You guys agree?
Yes.
Okay. So we got VB. Now, what else? How are we going to take this problem?
Now we get the speed of F, VF.
You can get the velocity of F. How can you get the velocity of F?
ما فينا ما مالش الأوميجا.
All right, so how many rigid bodies do we have?
4.
We have 1, 2, 3. We have 3. Okay. It's, by the way, it's called 4-bar linkage because you consider the ground as a link, right? So if you actually connect C to A, right, then this would be ground. Like the whole thing would be basically sitting on the ground. But essentially, we have 3 moving links: AB, BF, and then we have CD, right? I'm gonna give you guys a little hint, and maybe you can use the instantaneous center of rotation. Can you actually use the instantaneous center of rotation to, for example, maybe find the velocity of point F?
The circle is fixed, doctor, or no?
Yeah, the circle is fixed, so you are rotating about point C. So you can think of this here as simply a bearing.
فينا نبلش من C. نرجع نوصل ل F. بتلعب 2 equations to unknown ونجيبهم.
Okay, so if you start at C, you can say VF with respect to C, okay? And then you can say VF with respect to B.
Yes, بيطلع لها I وال J.
Bravo, yes, exactly. This is one way you can do it. Yes, you have 2 equations to unknowns. Why? Because you find VF with respect to velocity of C, and we know the velocity of C is 0, right? And then you can write the velocity of F with respect to B, and you already know the velocity of B, right? In that case, your 2 unknowns would be omega of BF and then omega of CF or CD, which is the same. Okay, very good. This is one way. The other way is to actually use the instantaneous center of rotation, right? And we said every rigid body is gonna be rotating about 1 point. If it's translating, then the point about which it is rotating is gonna be located at infinity, right? Okay, so what is the instantaneous center of rotation for the first link AB is obviously A, right? Because A has 0 velocity. But can I find the instantaneous center of rotation of link BF? Can someone tell me how can I find that? Okay, if I want to find the instantaneous center of rotation for this link, right, BF. So remember, I'm going to apply the process that we did, right? So you draw these perpendiculars line, right? So I'm going to draw this line. And then I'm going to draw this line, right? So the velocity of point F, right, is going to be perpendicular to here, right? So this is velocity of point F. I don't know how it's going to look, but I know it's going to look like that, right? Why? Because it has to be perpendicular to this link, because that link is rotating about this point. So if I actually continue this line all the way, I'm actually going to end up with that point, right? Here, like obviously I'm not going to draw it to scale, but let me see this. Do you guys see this line where this line is ending?
Yes.
Do you see this point? Okay. So this is my instantaneous center of rotation right here, right? This is point I. Okay. Now, if I want to find omega of link BF, how can I find omega?
مش هي omega cross R F مثلا.
Yes. So what I can do is I can say VB, right? VB. So point B belongs to the crank, and it also belongs to that link, right? BF. So I can say that VB is going to be equal to omega, right? Omega BF, right? Multiplied by BI, right?
Yes.
So, and actually I know VB, right? I know the value of VB. So VB is going to be the angular velocity of this link multiplied by that distance IB or BI. And so what I can do here is I know BI and I know VB, so I can find omega of BF, right? It's going to be equal to VB divided by BI, right? What is the value of BI? The value, what is the length of this guy right there? Well, I know this angle is 60.
0.3 divided by cosine 60.
Exactly, right? Why? Because I know BI cosine 60 is going to be equal to 0.3, right? So BI is going to be equal to 0.3 divided by cosine 60. Okay, do you guys still see my screen here?
Yes.
Okay. So now I got BI, now I can get omega BF is going to be equal to VB, which is 5, right? The value of it right now divided by 0.3 times cosine 60. So divided by 0.3 times cosine 60. So now we get angular velocity of BF, right? How can I proceed from here to be able to find the rest?
بس دكتور وقت عم تبرم ها ال 60 degrees ما بيتغير؟
Yes, it will. Exactly. So here we're finding the angular velocities at that instant. So later on, you're going to see from your kinematics is as this angle changes, omega is going to change, right? So for different motion here, right? For example, this link could speed up and then slow down, etc. So here we are finding the velocities and also the angular velocities at this snapshot, at that instant of this geometry. If the geometry changes, your angular velocities are going to change, because your angular velocities are also functions of the positions, etc. Right?
Okay, thank you.
So here you're finding these angular velocities at that geometry. If the geometry changes, your velocities are going to change, obviously, right? So this is my omega BF. Now I need to find the velocity at point F. How can I find the velocity at point F? So I know this is your rigid body, and then that rigid body is written about this instantaneous center of rotation. So how can I find the velocity of point F?
VF
Omega
equal
BF times Fi.
Exactly, right? Omega BF multiplied by Fi. And I know omega BF, and I still need to know Fi. So you guys get what I'm saying here, right? So you have this rigid body, Mahik, is rotating about this point. Okay, it's like, you know, the whole thing here is like, you know, translating, moving up like that. So I got its angular velocity. Once I get its angular velocity, right, and I know this point belongs to that rigid body at that instant, and it's some moving, so I can use it as a point, right? So this is why I can actually write this relationship here, and then omega. So I'm just gonna find what Fi is. So Fi is gonna be equal to how much?
0.3 times tan 60.
0.3 times tangent 60. So tangent 60 is going to be equal to Fi, right, divided by 0.3.
BF 0.3.
Exactly. So 0.3 multiplied by tangent 60. Bravo, very good. Tan 60. All right. So from here we can find VF, and let's say once we have VF, how can I find omega of CF? Let's say.
وبنجيب ال velocity of F with respect to C.
Exactly, right? So here VF is equal to omega BF. So I'm just gonna replace, right? So 0.5 divided by 0.3 times cosine 60, and then this whole thing, that is my omega BF multiplied by 0.3 times tangent 60, right? So here I'm just, and by the way, guys, we only have a minute left here. I'm gonna stop the recording so we don't miss information, and you guys can log back in to continue watching this. All right, so I'm gonna stop now, and then we'll come back, log back in. All right, guys. So now we obtained VF already from the previous, and now we're gonna try to find omega of link CD. I know VF is going to be equal to omega of CD multiplied by CF, right? And remember, omega CD is the same as omega CF, right? Same link. So here I'm going to get my omega CD is going to be equal to VF divided by CF, right? And I already know the value of CF is going to be equal to 0.075 meters. And there you have it. So if you were to find the velocity at point D, let's say, right, VD is going to be equal to omega CD, which you have it now, multiplied by distance CD. All right, so this is how we can solve these problems using the instantaneous center of rotations. The other way is going to be saying that VF is equal to VC plus omega cross RF with respect to C, and then VF is also going to be equal to VF is going to be equal to VB plus omega cross RF with respect to B. Okay, guys, so that is it regarding this problem. So let me actually quickly do this so we can see how it would look like over here. We have like 5 minutes left, so I think we can do this. So this is what we have. This is 50 here, and then I have VB. This is F, and this is C. So I can, just like what I mentioned, I can say VF is equal to VC, but I know VC is equal to 0, right? So this is like hinged like that. VC plus omega CF cross RF with respect to C. And then VF is actually equal to VB plus omega FB cross RF with respect to B. So VC is 0, VF is actually equal to VF. So I can write omega CF cross we already calculated omega, we already know VB. Here we have two equations and then two unknowns. What are the unknowns here? The unknowns are omega CF, its value, and then omega FB, right? And we don't know them, so what we'll do is, obviously, we're going to write omega CF is going to be equal to omega CF K, right? And then omega FP is equal to omega FB K, right? So let me quickly do that. So omega CF is going to be here more, right? Some more time. So omega CF cross R F with respect to C is equal to right. So what is RF with respect to C? So if you let me share this again. All right. So what is okay? So what is well, we said already omega CF is going to be equal to its value, like omega CF K, right? Cross what is RF with respect to C? So here you would actually need to calculate the angles, right? And I need to basically provide you this angle for you to be able to do this, right? You need to know this angle right there, right? Well, we know here this angle right there is 60. This guy is going to be equal to 90, right? And this guy here is also obviously going to be equal to, so you need to basically do the geometry and then you need to get this angle theta. And I'm gonna actually call this guy theta 1. You would basically need to solve for this to be able to solve that problem, right?
Doctor, is the angle 30? The theta?
This angle theta is 30.
Yes, because if we draw if we project AB on F, we draw a horizontal line on F. Therefore, the angle, yes, the
yes,
angle
exactly.
between, yeah, between.
So if this guy, if this guy is 60, then this guy is 60,
yes.
then this guy is 30, then theta 1 is 30. Exactly. So theta 1, bravo, yes, very good. So theta 1 is equal to 30, right? So if this guy is 60, right, then this guy is 60, right? This says, so this whole thing is 90, then this guy is 30, and then this guy has to be 30, right?
بس دكتور مين قالنا انه سي اف وبي اف perpendicular؟
They have to be perpendicular here. In the drawing, I would have to tell you if they are perpendicular. Otherwise, you won't be able to solve the problem. I need to tell you that these two are perpendicular. All right, so RCF is going to be equal to how much? Like 75 millimeters, right? So 0.075, right? Cosine 30i in the j direction minus, right? Minus 0.75 sine 30j. So your down is the first thing, and then VB. Remember, we said VB is going to be equal to 50 multiplied by 0.1j. Okay, this is very simple. What remains is omega FB cross R FB. Again, I don't know it, so I'm just going to put it omega FB. Okay, so this will actually tell me the direction of rotation. Cross RF with respect to B, which is directly given to me as 0.3 cosine 60i plus 0.3 sine 60j. All right, so I'm gonna let you guys continue this, all right, and then So هون what remains is you just put the i's together and then the j's together, right? You have two equations, two unknowns, and then you're gonna solve for omega CF and then omega BF. All right, and then you will basically get exactly the same result as the one that we just did. I'm gonna keep this as an exercise because we are basically running out of time. And then, so Friday actually is a day off, so we won't actually have a lecture on Friday, so we're gonna come back on Monday. And if I'm not mistaken, I believe next week is basically the last week. Is that what you guys are having in your other classes or no?
Having what?
Is it
The
like
last week?
yeah, next week is the last week of classes, or are you guys getting more lectures for 2 more weeks?
I don't know, not yet. ما حدا قالنا شيء.
Okay, all right. So I believe the semester is gonna end at May 15, but I want to give you guys a room to change to. So I believe we are going to have 3 lectures next week, and what I'll do is we may actually have more lectures the week after. But what I'll do is I'm going to pre-record some lectures actually from this. You know, to support you guys with. I may need to do that, so I'm not sure. But anyway, so Friday we won't have a lecture because it's Labor Day. All right. So I'll see you guys on Monday. All right.
Doctor, what
Yes.
time are your office hours today?
What time are my office hours? So I'm going to be available at any time today, like after 2. So if you would like to see me, just send me an email and then I'll be able to log in
Okay,
after 2.
thank you.
بس
Right.
دكتور كان عندي سؤال.
Yeah, sure.
هذا البروبلم اللي تبع البلوك والبولت وهيك حليته مثل ما انت قلت لنا، بس ما لقيت الانسر تبعي.
The problem قصدك هيدا that problem.
Yes, bullet block والspring.
Okay, so I'll tell you what. So there was actually an issue in the way that some of the images were uploaded. I know basically each student basically had a different numbers. So the numbers
Yes.
were different. Okay, so there was a little bit of a mix-up on Blackboard in the way things were done. So this is an issue on my end. But what I did is everyone that actually had these problems. So all of you guys had credits on these problems. Even if you had it wrong, basically, I gave you credit for it, like 15 points, because of the Blackboard mix-up. All right. So this was given to you basically as a free credit in exam 2. So all the students basically that had this problem or the bullet problem, basically they were given credit for this. You know, if your grade is not like 90 or 80 or it's not 100 or 95 or 90, then basically you had some mistakes on your true or false problems.
Okay.
Doctor, you will choose for each student أيها أعلى يعني
Yes.
and you will put it?
Yes, exactly. I'm going to choose the best grade of exam 2, right? If you didn't do well on the one that we did on last time, on Monday, basically, the one that we're gonna do, I'll choose the highest one in exam 2. هلا كمان there's one thing is there's Labor Day obviously on Friday, right? And I wanna see, when I was thinking to actually move it to Monday, but I will move it to Monday in the afternoon, for example, because we have a lecture during Monday. All right, so
بس دكتور سؤال، أنا ما زادت علامتي يعني بعد ما بس خلصت التست كانت 85 وما رجعت تغيرت. معقول كونوا أغلاط لأنه بس قدرت أشوف أغلاطي. معقول كونوا أغلاطي بالtrue or false.
let me see. Alessandro, right?
لا غدي زغندي.
غادي زغندي. Okay. Lake, why don't you? So I'll make myself available at 2 اليوم. All right. اللي عنده سؤالات regarding the exam, we can also answer it at that time.
Okay.
Okay, so we can log back at 2 and then I will be able. بس إذا ما تغيرت علامتك يعني basically you have true false problems. That's for sure.
Okay. Thank you, doctor.
All right.
If I want to log in back برجع فوت على هذا same link معك.
Same link, yes.
Okay, thank you, doctor.
Sure.
Thank you.
Okay, you're welcome.
Bye, doctor.
Bye. Thank you. Bye.